All right, hi. We are going to walk through the gel electrophoresis review activity. So when you open this in Canvas, if you haven't done so already, when you open this in Canvas, it's going to look like this, and it's going to start with a QR code. That QR code in the upper right-hand corner is the Amoeba Sister gel electrophoresis activity. So if you were not with me in class, you didn't watch this with me. If you were with me, we watched this all together on the front board, but if you need to go back and watch it again, you can scan this QR code. As you watch the video, you should be grabbing these questions or bullet points, filling these in along the way. So we should have the information there. The next thing here, next thing on our list of excuse me, on our procedure is to click here and click through a virtual lab or an animation of a gel electrophoresis. So you can click here. You do need to have a flash player for that. So once again, we did that in class on the old laptops. If you were with me, you clicked through it already. You do not need to click through that again. Finally, our last thing on the list here, we have a Khan Academy link. So if I click to open this, I can click here, and then in class we all typed in that bit.ly, but if I click here, it'll take me to a Khan Academy website. Hopefully yours loads a little faster than mine. And this link or website is devoted entirely to gel electrophoresis. So it shows us some vocab terms, it has some really great pictures, shows us the setup and how it works. Those can be helpful when you're knocking out these yellow questions or highlighted questions. A lot of these yellow highlighted questions can be answered with the video and the in-class animation. However, if you don't remember from class, or maybe you weren't here to click through the animation, then you're going to use the Khan Academy and you'll be able to knock them out that way. So we have just review questions at the start of class. What is gel electrophoresis? How is it used in DNA testing? Why are we using it for the antigen case? That's our goal for this first portion, just kind of familiarizing ourselves with gel electrophoresis. And then I'm going to scroll down and I'm going to get to a place that says review activity. The review activity says you're working in groups of 2 or 3. If you're listening to this video, you're working on your own, and that's all right. You'll be able to move through fairly quickly, and I'm going to help you along the way. So we're going to get started all together. It's going to tell you to read through the copy of the case of the Crown Jewels police report. What does that look like? Whoops, let's not go. Oh, here are all my photos. Very important stuff here. I mean, look at this. Okay. So police report, I'm going to go into notability, and I'm going to open it up. It looks like this. So it's just taking a few minutes to read through this. We have this formal police report. Formal because it's just city police department. If you look at the very top, it says there's been a museum theft. And if you look where it says property, it tells us what they have stolen from the museum, which in this case happens to be jewels. If you go a little bit farther down, it talks to us, or it gives the narrative, a little bit of a backstory on the stolen jewels. And then finally, the 4 suspects involved, a little bit of information over them. So we're going to take a minute, read through this to learn about the case. So we're not going to start with antigen. We're going to do a little bit of a practice with the crown jewel case. Okay, once we have familiarized ourselves with that, it then goes on to say or talk about a paper strip with DNA, right? So we have the paper strip with DNA that looks like this. And on this one piece of paper, you have crime scene DNA, suspect 1, suspect 2, 3, and 4. So we have 5 DNA samples on this one piece of paper. Now, in reality, the DNA sample came to us in the form of blood. Maybe it was hair that we were able to get it. Maybe it was a cheek swab. But when we sequence the DNA, we're able to see these nitrogenous bases and how they line up, or the order of the bases for each of the samples. Crime scene DNA is what we're trying to figure out. So we're going to eventually, at the end of this, match one of our 4 suspects back to the crime scene DNA. And if we flip back here, it's going to tell us how to do that. So in number 4, you're going to take on the role of something called a restriction enzyme. Restriction enzymes cut DNA samples. And when they make their cuts, so they're like a pair of scissors, they do so at a very specific place. Each restriction enzyme has its own place it makes a cut. All right, so they don't just cut anywhere. They have one specific sequence they search for, and they cut there each time they work or do their job. In this example, you guys are going to act like the restriction enzyme, and you're going to make the cut at the CCGG mark. So that's what we see here, CCGG. That's where our restriction enzyme is going to cut all the way through this activity. So when I go back, you may want to, let's see if I can get my text box. You may want to type that in just so you can remember, because that's going to be really important when we're going through this. So that CCGG pattern, that's for all of them. So we want to make sure we keep that in mind. Oh, I lost it. Hang with me. My notability skills are really not great. There we go. CCGG. You could say like cut at.
Leslie McDougall, if you're still in the building, could you please call 4403 Leslie McDougall?
That was fun for you guys to hear. All right, so I'm going to put that up to the side for us. All right, so now what we're going to do, we're going to read each DNA sample or sequence from left to right, and we're going to look for this CCGG pattern, because that's my clue. That tells me where I'm going to cut. So I'm going to change colors. All right, CCGG, I'm going to choose bright red. So I'm going to start on the left side of my screen, and right off the bat, I see CCGG. Okay, this is the pattern I'm supposed to be looking for, this section right here. So as the restriction enzyme, I'm cutting between CCGG. That's the job of the enzyme. Okay, how did I know that? That's what we were told in our reading. Cuts between the C and G. And then we see an example there. So I'm going to flip back, cut between CC and GG, and I'm going to continue to read left to right. CCGG, and I'm going to look for that pattern all the way through. And for my first one, which is our crime scene DNA sample, I find 3 places where I have that pattern, which means as the restriction enzyme, I would make 3 cuts. So for this one sample of DNA, I just cut it into 1, 2, 3, 4 fragments, right? Based on the number of times I found CCGG. Now that's going to be different for each of these, right? They're not identical DNA molecules. Only one person is going to match our crime scene DNA. So if I move into my next one, suspect 1, I'm still looking for CCGG, but notice my cut is at, right off the bat, my first cut is in a different spot than I had in the crime scene. CCGG. I think I got them all. CCGG. So in this case, I still have my 4 fragments, but my 3 cuts are in different locations. And you're going to find that for each of them. However, remember, we will have one that matches the crime scene DNA. That's the point of doing this. We want to figure out which suspect is going to match. Once you make your cuts, now's the really fun part, you get to count. So I'm going to change colors again. Right, when I say count, you're counting base pairs. So 2 base pairs. There are 2 letters that make up a base pair. So I'm going to go up here to the crime scene. So G and C would be 1 base pair. T and A would be 2, 3, 4, 5, 6, 7. So 7 base pairs. I'm going to abbreviate B, P, and fragment 1. So if we were to take the crime scene DNA and put it through a gel and run gel electrophoresis with it, we would see this fragment 7 base pairs show up on our gel. So if I go back here to my activity, okay, and this was our crime scene DNA. Let's go purple, so I'm here, crime scene DNA. And my first band that I just counted was 7. So over here on the right, I'll find 7. Where these two match up is where I'm going to show the DNA is going to leave a band in the gel for us to stare at or analyze. I'm going to go ahead and delete or erase those dots once that's done. Okay, and then I need to go back here because there were more. I had 3 more fragments. So I want to look at those 3 fragments that I have remaining. And here's the really fun part. You're going to actually count your fragments. So fragment 2 is a little long. So we're going to count that next. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5. I believe that's a 25 base pairs. Okay, next one is a 3, fragment 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 base pairs. And then finally, fragment 4 has 4 base pairs. So now I can add that to my gel. So I have a 25, 17, and 4. I'm still on my crime scene DNA. Now I have a 25, a 17, and a 4. So I would follow kind of what we did last time. So wherever my crime scene DNA and my 25, do the best you can to make it straight. And I do believe your notability lets you actually draw boxes. I'm just not very good at notability. So if you would rather put a small rectangle in, that's perfect. I'm going to do my 17 next. To represent, this would be a band. And then my 4. Each one of these bands is an RFLP, and we'll talk more about that in class. But this, now I'm finished with crime scene. These are my 4 fragments that I figured out on my other sheet. So I'm going to erase this, get these lines out of the way, get rid of that. So this is what our crime scene DNA sample looks like in a gel sequence. So now what I need to do is I need to find who else, what suspect has 4 fragments, and more specifically 4 fragments that are this size. So now instead of looking at all these letters and trying to figure out who it is, by having this system, it allows me to easily match a suspect with my DNA sample. And keep in mind, we're just looking at a very, very small chunk of DNA. In reality, we would be sequencing the genome. It would be a lot more letters, and it would make us lose our minds a little bit if we had to count all of this out by hand. So by loading our DNA samples into a gel, we could see the DNA fragments and make that comparison that way. So I'm going to do one more with you. I'm going to switch to a blue. Suspect 1. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 base pairs. So if I switch back here, suspect 1, I changed colors. It's just easier for me to see, okay, this is a new person. And I just lost my 9, that's what it was. So now I'm going to find 9 here and go across and give myself a band. And then I can erase this. Now at the end, big goal here, at the end of this, you are going to determine who matches with the crime scene. So whose DNA was found at the scene. So there will be a suspect who, like I said, has 4 fragments, but more specifically, 4 fragments in the same location as the crime scene DNA falls and the gel electrophoresis. So here you're going to tell me if it's suspect 1 here in this box. You'll put suspect 1, 2, 3, or 4. It is the person that matches with the crime scene DNA. Right? And then once you're finished with this, I'm going to erase this. You should have, at the beginning, we should have these questions answered. We have the video clip. We have the Khan Academy link. We have these questions answered. And then a completed gel with our suspect identified. As far as this document goes, you do not need to turn this in. So we used this to build our gel electrophoresis. As long as your gel is together, then you're good to go. You do not need to turn this in. Just make sure you're submitting this page so you can get those points. Okay, we're gonna follow this up in class with the actual gel electrophoresis lab. If you're not with me, you will just be excused from this lab, right? You've done kind of all the background work. You see how it works, hopefully. Let me know if you have questions, but you will be excused for the lab day. Okay, good luck. Reach out if you have questions. See ya.